What liquid melts ice fastest? Ice is a frozen version of water, and like snow, when it reaches a temperature warmer than itself, it starts to melt. I want to know which beverage melts a single ice cube fastest. What type of water will I use for the ice cubes? When I freeze the ice cubes, I will use tap water. Tap water can contain a variety of different minerals such as calcium, magnesium, and sodium. Next slide of background information. The beverages I will be using are 1% milk, tap water, Coca-Cola, freshly carbonated water, and orange juice. I'm going to use the same type of ice cube tray for each ice cube so they're the same size. Maybe in the future, if I wanted to take this further, I could test the sizes of the ice cubes. The chemical formula for all these beverages are tap water, H2O, milk, C12H22O11, Coca-Cola. Coca-Cola does not have a chemical formula, it has a chemical composition, which includes water plus sugar plus color plus caffeine plus CO2. Carbonated water, H2CO3. Orange juice. Orange juice does not have a specific formula. Orange juice is a mixture of multiple substances such as water, glucose, and citrus acid. Orange juice also contains traces of minerals, vitamin C, and potassium. Background information, part 3. If I had to make a guess which beverage would melt the ice fastest based on the chemical formulas, I would choose Coca-Cola because Coke has multiple components that can work together to break down the ice. All of my beverages will start at the same temperature as best as I can control. Hypothesis. I think that the Coca-Cola will melt the ice the fastest for one main reason. Coca-Cola has many components that can break down ice. I think the carbonation and sugars will break down the ice quite quickly. I made this guess based on the chemical formulas of all the beverages. I think the total placings will be first place, Coca-Cola, second place, carbonated water, third place, tap water, fourth place, orange juice, and fifth place, milk. Methods and equipment. First, my equipment. I will need 5 glasses, 5 of the same sized ice cubes, 1 cup of each beverage, which is 1% milk, tap water, carbonated water, orange juice, and Coca-Cola, a timer, 5 spoons, and labels so I know which drink is which. My step-by-step procedure. I'm going to do each beverage all at the same time, so this is for all the beverages. First step, pour 1 cup of the designated beverages into each large glass. Step 2, check the temperatures of all your drinks so you can add them to the presentation. I check the temperatures just with a chicken thermometer that you would stick into a chicken. Step 3, take your same sized ice cubes and without touching them, place them on the spoons above the drinks. Step 4, drop the ice cubes into the drinks and start this timer the second it hits the liquids. Step 5, stay by the glasses and with a spoon, take the ice cubes out to check every 5-ish minutes. Step 6, when the ice cube is completely melted in one of the drinks, check the timer and write down the time on a piece of paper. When you set up your experiment, make sure your beverages and ice cubes stay at the correct temperature and make sure everything is set out so it's easy to access when needed. The ice cubes are going to be, and were for me, negative 17.77 degrees Celsius and the beverages at 16 degrees Celsius or around room temperature. Now for the experiment. Here's a before picture. As you can see, there's Coca-Cola, tap water, orange juice, carbonated water, and milk with labels and a spoon for each of them. First observations, carbonated water. The carbonated water was the first beverage to melt the ice cubes. It didn't take very long for the ice cubes to dissolve, and the carbonation ate away the ice the entire time. The carbonated water took 7 minutes and 9 seconds to melt the ice. In picture number 1, it's melted down a little bit, but the ice cube, when we first dropped it, was a bit bigger. At 3 minutes, it's turned into a thin slice of ice, as for the carbonation has been eaten from the sides, has been eating around the sides to the inside. At 6 minutes, it's just a tiny, tiny, tiny little cube in the corner. Tap water. The tap water was the second beverage to melt the ice. It melted not much longer after the carbonated water and took 9 minutes and 56 seconds to dissolve the ice. At 1 minute, it's fairly the same size as when we dropped it. At 3 minutes, it's slowly progressed progressing down to smaller. 6 minutes, still there, but still small. And at 9 minutes, it's once again the tiny cube in the corner. Orange juice. The orange juice was the third beverage to melt the ice. The orange juice took quite a bit longer after the tap water, close to double the time. The orange juice took 16 minutes and 35 seconds as a total time to melt the ice. At 1 minute, you can see it. It's kind of hard to see because orange juice is an orange liquid, but it's the same size as when we dropped it. At 3 minutes, it hasn't dissolved a lot, but I'm assuming that it's eating away from the bottom where you can't see. At 6 minutes, it's still around the same size. 9 minutes, still kind of there. At 12 minutes, it went down quite a bit, and it's just a little bit. And at 15 minutes, it's just a little cube in the middle. Milk. The 1% milk was the fourth beverage to melt the ice. I had originally thought that the milk would be last, but it wasn't. The milk came out with a time of 18 minutes and 30 seconds. In 1 minute, the ice cube's still the same. At 3 minutes, once again, still the same. At 6 minutes, it's starting to melt down a bit. At 9 minutes, still around where it was at 6 minutes. It was a very slow progressor. At 12 minutes, it's melted down quite a bit. 15 minutes, it's just a little bit in the corner. At 18 minutes, it's just really, really tiny. Coca-Cola. The Coca-Cola was the fifth and final beverage to melt the ice. Surprisingly, I thought the Coca-Cola would be first, but the experiment proved me wrong. The Coca-Cola had a final time of 21 minutes and 27 seconds. At 1 minute, it's still the same size. At 3 minutes, it's getting eaten away by the sides. At 6 minutes, went down a bit. 9 minutes, still pretty much the same. At 12 minutes, you can see a bit of an indent in the side. At 15 minutes, it's a lot smaller. And at 18 minutes, it's a small cube, as that was a pattern for a lot of them. By their final time, they were pretty small. Conclusion. As a result of the data of my experiment, the placings for my beverages are as follows. First place, carbonated water. Second place, tap water. Third place, orange juice. Fourth place, 1% milk. And fifth place, Coca-Cola. After I examined the data, I thought, why did the Coca-Cola not come out on top but the carbonated water did? After some quick research, I concluded that the Coca-Cola didn't come out first because Coca-Cola has sodium in it, and sodium makes ice melt slower than normal water. In order for the ice to melt, the chemical bonds that connect the molecules must be broken, and breaking these bonds always require energy. Adding sodium means it will take longer and more energy to break the bonds. This is my chart and graph. That's not showing up. Mr. Smith, do you think you could just reload it?
I think so.
Yeah, because it came up on 5, which represents the minutes. The smaller the bar, the less time it took. And as you can see in a comparison from the first to last beverage, it was quite a jump. And it's just a good comparison to see which beverage melted slower or faster than the other. So, we need to scroll because it's not a presentation. Different types of Coca-Cola, or 5 different types of juice, like 5 different kinds of milk, all that stuff. Then I could further my understanding of which one of the multiple types of Coca-Cola, carbonated water, tap water, milk, and juice would melt the ice fastest. I could also change different variables in the experiment. For example, I could change the size of the ice cubes, change the amount of liquid, or change the type of water used in the ice cubes. There are so many ways to investigate liquid versus ice. I enjoyed running this experiment and encourage you to look more into this topic if you found it interesting. Sources, there aren't very many. Any questions? All right.
Yay!